Line spectrum of hydrogen. Line spectrum of hydrogen. Okay. Line spectrum of hydrogen. Balmer is the first scientist. He did the experiment by using hydrogen gaseous atoms. Okay. In 1885, Balmer did an experiment by passing electromagnetic radiation on hydrogen containing hydrogen atoms containing sample. He did an experiment by passing electromagnetic radiation onto the sample. Sample contain gaseous hydrogen atoms. Gaseous hydrogen atoms. Okay. He passed the electromagnetic radiation. Mainly it contains white light. Various electromagnetic radiations. UV radiation is also electromagnetic radiation, IR radiation is also electromagnetic radiation, and visible radiation is also electromagnetic radiation. He takes only white light. It means visible radiation. In electromagnetic radiation, he preferred white light is passed into the sample. Okay, he passed the electromagnetic radiation. Electromagnetic radiation mainly contains white light. Okay, in electromagnetic radiation, he takes white light. Okay. Remaining part he did not do the experiment with the remaining electromagnetic radiation. He only preferred white light or visible radiation range. He only preferred that range. He passed visible radiation only. So the remaining parts UV, IR radiations are also electromagnetic radiation. With that radiations, some of the other scientists do the experiments laterally. The first is the Balmer is the one person in 1885 he did the experiment by passing white light into the hydrogen atom. The sample contains the hydrogen atoms. Okay, white light is also belongs to electromagnetic radiation. That is the reason why you call it as electromagnetic radiation is passed into the sample. And he observed absorption spectra and emission spectra. Okay, then he observed absorption spectra and emission spectra. Okay, whenever he passed the white light into the hydrogen atoms sample containing sample, he observed absorption spectra and emission spectra. Okay, how then he can explain the absorption spectra and emission spectra with respect to the equation given by the Rydberg. Rydberg is the scientist. He has given the one equation. Wave number is equal to 109,677 into 1 by n1 square minus 1 by n2 square. Okay, square bracket centimeter inverse. Okay, using that equation he can explain the his experiment based on that equation, based on that one. Okay, absorption spectra AB, absorption and emission spectra. Okay, he observed by passing white light in this electromagnetic radiation, he can observe absorption spectra and emission spectra. Okay, it can gives absorption spectra. Bright line absorption spectra contains dark lines. Okay, dark lines which we are discussed in previous class. Okay, emission spectra gives bright lines, BRIGHT, bright lines. Okay, we know. Whenever he passed into this one, okay, initially we can get absorption spectra, and then laterally atoms absorb the radiation, then we can get the absorption spectra. Whenever atom goes to higher energy state, it is unstable, then electron come back to the ground state, then it can give the emission spectra. That is the reason why you can observe two types of spectrums. Okay, two types of spectra, absorption spectra and emission spectra. For line spectra of hydrogen atom, Balmer did this experiment. Okay, he explained his spectral lines by passing white light into hydrogen atom. You should explain these two concepts by taking the one law. This is 109,677 1 by n1 square by 1 n2 square. This is introduced by Rydberg. This is the scientist name is Rydberg, R-Y-D-B-E-R-G, Rydberg. Okay, Rydberg has proposed this equation. Rydberg has given this equation. So the scientist name is Rydberg. The constant is Rydberg constant. Rydberg's constant. Okay, this is known as Rydberg's constant. Okay, Rydberg has given this formula. On experimental data, Balmer, he was explained his experiment, these lines by using this formula. By using his formula, okay, he can explain his experiment. Okay, Balmer has did this experiment, he get the dark lines and bright lines. Okay, then he will take his formula for the explanation of his experiment. Okay, then he explained his experiment by taking this formula. Okay, like this. Wave number, nu bar means wave number, which is indicated as 1 by lambda. 1 by lambda. Okay, is equal to wave number. This is known as wave number. Nu bar is known as wave number. Wave number means 1 by lambda. Okay, nu bar is equal to 109,677 1 by 2 square by n2 square. He can explain these two experimental data by using this formula. Okay, Balmer is the first scientist. He can explain his practical by borrowing this formula like this. Okay, from this we understand how do we understand the Balmer lines is. Okay, let us understand these Balmer lines. Okay, whenever electron goes to okay, n1 is equal to 2, n2 is equal to higher numbers 3, 4, 5 and so on. Okay, whenever electron goes to n1 is equal to 2, n2 is equal to 3, then there is a absorption. Absorption of radiation takes place. So there is a absorption. Okay, then it is also, you may write like this, n2 is equal to 4. This is also Balmer series, which is also in Balmer series. Balmer explained that in this experiment he observed whenever white light is passed into the sample, it can give the two types of lines. Okay, these lines as explained as initial stage is 2, the final destination is, it may be 3, it may be 4, okay, final destination it may be 5 and so on, 6, whatever it may be, n is infinity. These lines are belongs to the Balmer series absorption. These lines belongs to the Balmer series. First he explained. Okay, he is the first scientist. He can explain whenever white light passed into the sample, he can get the two types of lines, dark lines and bright lines. To explain this, he borrowed this principle, this equation from the Rydberg, and he has explained initial stages. Atom has levels, atom has the energy levels. Whenever electron goes to initial stage, starting point, n is equal to 2 to 3, then it is a Balmer line. 2 to 4, it is also Balmer line. 2 to 5, whatever it may be, the starting point is 2, the energy levels is known as Balmer series. Okay, the starting point it is 2, then you can get the Balmer series. There are so many lines in Balmer series. Why? You can get different lines for a particular atom. This same principle which we are also already discussed, that in hydrogen atom electron goes to 2 to 3. In some atom, in some cases, in hydrogen has in this sample there are different. There is a number of hydrogen atoms, not single hydrogen atoms. There are so many hydrogen atoms. In a particular hydrogen atom, one particular hydrogen atom, electron goes to n is equal to 2 to 3. Okay, whenever electron goes to n is equal to 2 to 3, then you can get the one line. Whenever take another atom, it may absorb greater amount of energy in white light. In white light, you know, 7 colors, white light contains 7 colors, 7 colors contains different energies. So this atom absorbs only limited energy, another atom absorbs maybe greater energy. So that electron goes to n is equal to 2 to 4. That is the reason why you can get the another line. In another atom, electron takes greater energy from the it takes greater energy from the white light. So n is equal to 1 to n is equal to 5. Okay, electron goes to n is equal to 1 to n is equal to 5. Okay, which can give another line. So that is the reason why so many lines are observed in Balmer series. But the electron transition is fixed. Starting point is 2, ending point is infinity. N is equal to 2 to 3, it belongs to Balmer series, Balmer lines. N is equal to 2 to 4, it belongs to Balmer lines. N is equal to 2 to 5, it belongs to Balmer lines. Okay, the starting point is 2 and ending point is any one, it belongs to the Balmer series. It gives the absorption spectra idea. Okay, we have another idea, that is, what about emission spectra? Now we discuss the absorption spectra of hydrogen atom. What about emission spectra? In emission spectra, it is the same case. Whenever electron goes to in emission spectra, electron comes from higher energy level to lower energy level. So in this concept you can understand that, we can understand like this. This is absorption, next emission. If n2 is equal to 3, then n1 is equal to 2. n2 is equal to 4, then n1 is equal to 2. Reverse this, reverse of that one. gives the emission spectra. Okay, N2 is equal to 5, N1 is equal to 2. So electron comes from higher energy level 3 to 1 is known as, it is also Balmer series, but it is emission. Radiation is emitted. This is excited sample only gives the spectral lines in emission spectra. Okay, this is known as emission, this is also emission, this is also emission spectra. Okay, it can gives the bright lines, it can gives the energies, they give the energies, though it is known as emission spectra. Okay, this is known as emission spectra. 3 to 2, 4 to 2, 5 to 2. This is known as emission spectra. Emission spectra. Okay, Balmer first explained this. Balmer first explained this type of particle by using Rydberg equation. He draw this. Okay. Next, line spectra. Next, another scientist, after some time, another scientist come into the light. That one is Lyman. Okay. Next one, Lyman. Okay. Next, another scientist come into the picture. That is one is Lyman. Okay. Lyman used the energy electromagnetic radiation is UV radiation. UV radiation is much greater energy than compared to the Balmer. So he used the light UV, same hydrogen sample. He also observed absorption spectra and emission spectra, same case. And he also explained taking this one into one to any level, which can gives the Lyman series. In absorption, Lyman explained like this: N is equal to 1, 2, 3, 4 and so on. Okay, and initial stage is 1, 1, 1. Okay, final stage is 2, okay, 3, 4, 5. If the electron goes to N1 energy level to N2 is known as Lyman. If electron goes to N1 to N3 is also Lyman, 3 to 4. The starting point is 1, the ending point anything is known as Lyman series. That one is absorption spectra, which we understand that it is absorption spectra for Lyman. Lyman also given the emission spectra. In emission spectra, electron goes to electron comes from the 2 to 1, 3 to 1, 4 to 1, anything comes from any energy level goes to from any energy level to the ground level, any N1 is equal to 1, then that is belongs to the emission spectra of Lyman series. Okay, which is Lyman did the practical by using UV light. By using UV light, he did the same experiment. He can also get the absorption spectra, emission spectra. He can explain absorption spectra from electron from N1 to N2, N1 to N3, N1 to 4. Okay, like this. This is absorption. Electron goes to from 1 to 2, 1 to 3, 1 to 4, 1 to 5. These are comes under the absorption spectra of Lyman. Okay. He also explained emission spectra for hydrogen atom. Okay, energy level N2 to N1, 3 to 1, 4 to 1. All are comes from any level to 1 is indicated by the emission spectra of Lyman series. He also expressed Rydberg equation, nu wave number is equal to 109677 into 1 by, okay, n1 is equal to 1, n2 is equal to 2, 3, 4, like this, so on. Okay, he explained this one. Lyman explained the spectral lines by using this formula, by using Rydberg's formula. Okay. Next scientist will come into the force. He also explained this one, that come into the under Paschen. Next one is Brackett. Next scientist Brackett, and next scientist Fund. Okay na? Next scientist Fund. These are the scientists. These are the science. 5 number of scientists can explain electromagnetic spectra. Electromagnetic spectra of line spectrum of hydrogen. Line spectrum of hydrogen atom. Okay. You can write down the final picture how you can explain the whole concept. Okay, let us take this one. Lyman, Balmer, Paschen, Brackett, Fund. Okay, he explained the lines. Starting point n1 is equal to 1, 2, n2 is equal to 2, 3, 4, and so on. Next, he is explained to final stage n2 is equal to 3, 4, 5, and so on. Next, Paschen explained n1 is equal to 3, n2 is equal to 4, 5, 6, and so on. Next, Brackett equal to 4, n2 is equal to 5, 6, 7, and so on. Okay, next, Fund, n1 is equal to 5, n2 is equal to 6, 7, 8, and so on. Okay. Lyman, in Lyman series, electron jumps from n1 to n2. In Balmer, electron jumps from 2 to 3. In Paschen, electron jumps from 3 to 4. In Brackett, electron jumps from 4 to 5, or 4 to 6, or 4 to 7, like this. Next, Fund, electron jumps from this one to this one, and this one to this one, and so on. So, you can explain the spectrum, line spectrum of hydrogen by using this methodology, this idea. Next, the region, electromagnetic region. Lyman explained his lines, UV region. UV light, he explained his region, electromagnetic region. EMR region, electromagnetic region. Okay, electromagnetic region, UV. Balmer take visible radiation. Okay, Paschen, IR radiation. Brackett also taken IR. Okay, the remaining scientist explained his practicals by taking these regions. Okay, always Lyman's series explained. Electron goes to n1 to next energy levels 2, 3, 4, and so on. Next, Balmer can explain his series from n1 is equal to 2 to n is equal to n2 is equal to 3, n2 is equal to 4, n2 is equal to 5, so many, like that. Same way, Paschen has explained his lines by taking IR radiation. He passed the IR radiation through the sample. He get the lines. These lines are explained by Paschen like this, taking these numbers. Okay, And another scientist comes into the light, next bracket, he did the same experiment, the previous ones they are did the same. He did the experiment bracket from his idea n1 is equal to 4 to n is equal to 5, 6, 7. So he also succeed by taking IR radiation passed into the sample. Next scientist in Fund is come into the light and he gives the he did the experiment by passing the electromagnetic radiation IR radiation into the sample, then he get the lines. Okay, he has explained electromagnetic radiation, electromagnetic spectrum. Okay, these are the radiations they passed into the samples. These are the radiations. The region means Lyman passed the UV radiation, Balmer passed the visible radiation, Paschen passed the IR, he is also passed the IR, So by passing these radiations, they will get the electromagnetic spectrums. They were explained the electromagnetic spectrum by using Rydberg equation. Nu bar is equal to 109,677 into 1 by n1 square minus 1 by n2 square centimeter inverse, we know. Okay, what is the n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 5, n is equal to 6, n is equal to 7, n is equal to 8, the lines are. Okay, whenever electron comes from second level to one level, and then whenever electron comes from second level to first level, and whenever electron comes from third level to one level, fourth level to one level, okay, next fifth level to one level, okay, sixth level to one level, okay, seventh level to one level. Okay, these are the enough, I think. You may write down another line, 8th line to. These lines are known as Lyman series. Okay, this is mainly observed in emission spectra. Electron comes from second level to one level, third level to one level, fourth level to one level, any level to number one is known as, it can give the spectrum. Because of these transitions, we can get the spectrum, or that spectrum, the spectrum is Lyman spectrum. Okay, electron comes from second level to one level, third level to one level, fourth level to level. Because of these transitions, okay, which takes place in an atom, okay, in a different atoms, not in a particular atom. One atom cannot give all the lines. Okay, one particular atom can give these lines, another atom can give this one, another atom. Different atoms can give this type of lines. Okay, by passing UV light, you can get these lines. Okay, this is studied by the Lyman. This is known as Lyman lines. Okay, next case, another scientist. This is emission spectra. Whenever electron comes from third to second level, and same way fourth to second, fifth to second, okay, sixth to second, seventh to second, eighth to second, okay, any energy levels 2, electron comes from in a particular atom, electron comes from higher energy levels to second level. Okay, you can get some atomic spectra, emission spectra for hydrogen atom. Then these lines are known as Balmer series. These lines are Balmer series. Okay. These lines are Balmer series. These lines are Lyman series. Next scientist we know 4 to 3, okay, 5 to 3, 6 to 3, okay, 7 to 3, 8 to 3. These are studied by the Paschen. Okay, Paschen series. Paschen series. Next one is, okay, any level to third level is known as Paschen series. Any level to third level gives the Paschen series. Any level to second level, Balmer series. Any level to first level, Lyman series. Like that you can remember easily. Next, any level to fourth level. Any electron comes from any level to fourth level. Okay, which can give the spectrum. That is known as any level to 5th to 4, 5, 6 to 4, 7 to 4, 8 to 4. Okay, it can use this spectrum. These spectral lines are known as, okay, Lyman, Balmer, Paschen, bracket. Okay, bracket. Okay. Okay, bracket. Next one. Electron comes from any level to fifth level. Any level to fifth level is known as fund. P-F-U-N-D, fund. Okay, any level, fifth level, 6 to 5th, 7 to 5th, 8 to 5th. 8 to 5th is known as fund. Okay, it is also indicated by fund series, bracket series, okay, Paschen series. Like this you can understand. Emission spectra. Sir, what about the absorption spectra? Okay, did you write the absorption spectra for this hydrogen atom? Okay, you may write it. Okay, easily. Same, reverse it. Reverse the this one, you can get the absorption spectra. Reverse this one, when electron goes to an absorption, electron goes to N1 to N2, N, reverse. The arrow mark reverse to this one, you can get the absorption spectra of the line spectrum. You can get the absorption spectra by reversing the same concept into reverse this one. Electron goes to N1 to N2, 1 to 3, 1 to 5, okay. Indicate the arrow mark like this, you can get the absorption spectra. Same Lyman, scientist names does not change. Scientist names does not change. You can get the absorption spectra on that way. Okay, this is the this is about the line spectrum of hydrogen atom. It is very important for intermediate public examination, and this is the very important question for the intermediate public examination. Thank you.